Given n non-negative integer representing an elevation map where the width of each bar is 1, compute how much water it can trap after raining water. So the blue ones are the trapped water. So the block is the height, or like the wall. So given this height here, the answer is 6, because you can basically fill this gap here. Notice that if it's on the edge, you exclude the edge. Like this one should be 3, right? This is the height of this is 3. But what's happening is you don't basically include the edge, so you exclude the edge. Okay, so how do we solve this? So maybe we'll break it down to problem into something like this. So this is your map, right? Notice that in order for you to compute the water here, you basically have to find the highest border, which is on the right, which is 1. For example, this is 1, right? So you basically 1 minus 0, which is the height of the 0, so you get 1. So you get 1, 2, 3, and then 1 here. So in here, you gotta find the highest border when you're scanning to the right. So in this case, you scan the right 2, find 2 here. So 2 minus 1, got 1. 2 minus 0 is 2. Now here's the tricky part, because you notice that it's 3, but when you go to the next one, 2, you don't basically compute a 1 here. This one, you don't 3 minus 2. The reason for that is because there's no other border that is greater than 3 on the right side. So the idea here is you need to find the highest border. Basically, you can't just basically just use the previous. You also need to find on the right side, the highest border on the right side. So if you think about that formula, you're basically trying to find the minimum between the left and the right border minus the height. That's basically how you compute the water filling. So how do we do this? So this is your index, right? So what we can do is basically scan to the right, and then store the highest minimum on the left on an array, something like this. So in this case, you go for index 0, the highest is 0, index 1, the highest is 1, 1, 1, and then it becomes 2. The reason why it becomes 2 because previously there's already a 2 here. It's 2, 2, 2, 2, 2, 2, until here 3. Now 3 is the highest, so everything here will be 3. So once you calculated that, you temporarily store that in some array, so you know that's the highest on border on the side. Now what you need to do now then is scan from right to left. So instead of left to right, this is the first step, is scan left to right. Now scan right to left. So why do we need to scan right to left? So in order for you to find the border on the right, same thing as what we're doing. So the highest border on the right is basically, this is still 0. Yeah, because it's on the edge. You basically start your max as 0. Now you go here on this order 2. Basically, when you height 2, you will still use the previous one. Notice here we always use the previous one. So now the highest max on the right side is the previous, which is 1. Now we got 1. The highest on the 1 is 2, right? 2 is still 2, 2, 2. That it becomes 3. So everything here becomes 3 now. So you notice now we have two arrays for the minimum, right? But yeah, and then what you only need to do is basically find the minimum between these two. The minimum between 3 and 0 is 0. 0 minus height, which is negative 1. If it's negative, you just basically make it 0. Right? So yeah, this one is 0. And then the minimum between 1, 3 and 1 is 1. So it's still negative, you just ignore it. So now here, this is where we got the calculation correctly. So the minimum between 3 and 2 is 2, actually 2. 2 minus 1, which is the height. Now you got a 1 here, which is positively. And here, the minimum between 3 and 2 is still 2, but the height is 2. 2 minus 2 is 0. So yeah, and then you just basically add all of them. Same case here, right? The minimum between 3 and, in this case now, the minimum 3 is 3. Minimum 3 and 2, now you're gonna use 2, and then you subtract that with the height. So that's how you basically calculate it, and you just add all of them in the result. I would say that's the most optimal way of doing this, and maybe we can start writing the code for how do we do this. So in this case, we basically have to have a max variable, right, which is starting with 0. So for I call 0 is less than blah, blah. So we need to find a way to store the right side height. So in this, I'm gonna create an array which is L, which is left, equals new basically int which is the length of this, which is n. Basically, just make this as a variable n, and then make this as n. So every time I go in here, I'm gonna store my max, right? So li store max, and then my max, basically you calculate math.max between the max and which is height. Alright, yeah. So this is the first part. So we build this array here. Yeah. Now we're gonna scan right to left. When you scan right to left, so this is n minus 1, and then greater than equal to 0, and then I minus minus. See, same thing, we still have to calculate the max here, but in this case now, what we need to do is basically find the minimum between the left and right. So now you need to do something like math that min started in a temporary variable. The minimum is on the minimum between this one, which is your li, this position, and then your, so means we're scanning here, right, from the right side. You know that the height of this, the max is 0, is the max. Yeah. And we recompute the max again from here. Similar to this, we compute the max here. Real time, we're gonna go, and then we need to put the result in a array result, in an integer results. So we just create a variable called res, and then what we can do is res plus equal math dot max. Because it's possible that it's negative, so you put the 0 if it's negative between the temp minus the height, which is I, right? And then we return the result. So basically, this is the formula that you have: minimum between left and right minus height, and then that's just what we have here. So let's try to run this out. There you go. Seems like it's correct. Well, let's submit it. Okay, there you go. It's 1 millisecond. So this is how you actually solve this. So thank you for watching. If you like this video, please hit like and subscribe, and we'll see you again in the next episode of LeetCoding.